Hi, I'm Bob DuBard. Welcome to Ransom Everglades. This is a school in Miami, Florida, and we have here our FarmBot XL. This is the size of it. It's wide and longer than the standard FarmBot, and this is version 1.4. The video we're going to do today is about solving some of the problems one might have with movement in the X direction, the long dimension here of the device. You can generally divide problems of moving in the X direction into three categories. There's mechanical issues, there's electrical issues, and then finally there's sort of program issues, the way you've set up the app online to do things like enable the encoders or reverse the direction of the motors. So we're going to explore all of those different problems to try to get this to move well here today. So mechanically we've got the FarmBot set up here pretty well. But when I attempt to move it along the x-axis using the app here, and I tell it to go, it just kind of jiggles in place. And this confused me a lot. It took me a while to figure out. I thought maybe the motors weren't getting enough power or something was binding down in here. And then I realized it had to do with the software, that I needed to go into the device settings and check several different things. One of the things that caused this was I had my x-axis encoders inverted. And so what was happening is the FarmBot brain over there was telling these motors to go in one direction, but the encoders thought they were going in the other direction. So it just kind of jiggles in place. And I've turned that off now. I've inverted it back the other way. And so now when I tell the FarmBot to move, go. Now I see it's attempting to move in the right direction, but it just doesn't seem to have enough energy to be able to move that way. And I was really confused about that. And so I said, well, first let me make sure that if it weren't bound up, if it weren't getting caught, something else wasn't the problem. So what I need to do, if you zoom in right here, if you look, this stepper motor has this belt over it right here. And this is what makes it move back and forth. When that motor turns in different directions, it moves the gantry in one direction or the other. And so if I want to eliminate all the friction, what I need to do is loosen that belt. So let me show you how to loosen that belt. So this belt that runs over this stepper motor runs down to the track and along in this groove along the track to this screw right here. And so this is how we're actually going to take all the belt tension off of that motor. We're going to loosen the screw right here. Loosen a little bit more here. I'm going to slide it forward a little bit. So now we got a lot of slack in that belt. We'll move back up here to the stepper motor. Just lift this belt off of there and let it sit down. So now this motor can turn freely. It doesn't try to move the gantry or anything. The motor's literally trying to drive by itself. And in fact, this is how I found out that that inverted encoder thing was a problem, because with no load on it at all, they still wouldn't move. I'm going to loosen the one on the other side, and then we're going to do a little testing. So when you have trouble with the x-axis moving, there are a couple of things that can be wrong. One of the things, of course, is anything mechanical. If there's something jamming it, if there are plants in the way, if this isn't adjusted to be perfectly straight and square, if these rollers are too tight, then that can physically prevent it from moving well. But at the same time, you can also have problems with the setup, with the way it's wired in to some degree, but very importantly in the app, how you've set up your encoders or the directions of your motors. There are two motors that operate to move along the X, especially on the FarmBot XL, the really wide one here. And so to get these to agree on which direction is which, for them to work together and synchronize, for their encoders to work right, there's several different settings. What I've done here is I've removed the belt from this motor so that it's free to spin, so I can just watch it operate and thereby eliminate any of those mechanical problems I mentioned. I've done the same thing on the other side of the x-axis gantry. Now if I go into the app, under the controls here, and I just tell it to move along the x-axis, I don't know, a meter or so from where I am, and I tell it to go, I get these minor twitches. You'll also notice, very important, that this motor, which is the second x-axis motor, it's X2, was turning such that the side closest to you was going upward. If we go look at the other side, we can see the similar see what behavior it gets under similar commands. So again, I've removed the belt, so I've showed you how to do that. So you've isolated the mechanical problems from the software problems. I'm going to give it the same command now. I tell it to go, it jerks, but you'll notice the side nearest you went downward here. This means that these two motors are going in opposite directions. It means it's going to try to take that gantry and move one thing north and the other one south, so to speak. And that's not going to work. So first off, one of the motors has to be inverted. There is an option for inverting both motors, but there's also an option for just inverting the X2 motor. So I'm going to go into the software, I'm going to invert that motor so that at least these two are in the same direction, and then we'll observe what it does under after that change. So now I've inverted X2, the second X motor, and we'll see if that solves our problem. Again, I'll give it a command to move a meter or so. We'll zoom in on this one first, which should still be doing the same things it was before. Still not giving us a continuous motion, but it's moving downward near you, so it's headed north if we want to say toward you as north. We'll go back over to the X2 axis. Give it the same command exactly, and you'll notice it's moving the same direction. It's still not moving continuously, but at least both motors are moving the same direction. So I had to play with that X2 inversion until they were both going in the same direction. Now, as I said, there's also the option in the software to invert both of your motors. I'm sorry, not to invert both your motors, to invert your encoders. And I had the encoders inverted on this, which I believe meant that the power going to the motors was telling it to go that way, but the encoders were seeing it going that way. And so it realized it couldn't function. So by inverting the encoders, now I can go back into the app, I can give it the same command again, and now you see we get nice continuous motion. And the other side should do exactly the same. Oh, I got a couple of little spots there where it seemed to kind of bind up. Much better progress though. We're getting where we want to be. Let's check the other motor just to make sure that it does the same thing, runs continuously for a period of time in the same direction. So back over to here, I'm going to tell it actually to go the opposite direction now because it thinks it made it to where I told it to go. So this will be going the other direction now. We're still getting these occasional stops, but longer runs. So at this point, I was a little confused. It wasn't a software issue. The two motors are turning in the same directions. The encoders are agreeing with the directions they're going. The problem we have now is one of there's simply not enough current going to these stepper motors. So the way you address that is actually you have to open up the box here for FarmBot and do some adjustments. We have this wire right here that says X1, right? And we have X1 encoder. So this plug right here, I'm actually going to power this down so I don't ruin anything. This plug right here is actually sends the encoder data from the stepper motor into FarmBot. Likewise, up here, you'll see it says X1 motor. This is the actual power cord to that motor. So these two together make up a pair. They'll go to a particular motor. If you think one of your stepper motor drivers has gone bad entirely, a way to check that is swapping. So we can, for instance, if I know my Y-axis is working fine, I could unplug these guys from the Y-axis and make sure they're labeled before you move them. If they're not labeled, it can get really confusing really quickly. So let me, and these guys have a little clip you have to depress when you're pulling them out. So I've taken the Y1 loose and I'm going to plug the X1 where it belongs. Now obviously when I go to test this motor, I'm not going to give it X commands, I'm going to give it Y commands. So in the app, I'm going to tell it to move along the Y, but the X motor here, X1 motor, should move. Let me show you that real quick. Give a command in the Y direction, tell it to go. This motor's running. And see, that's running very well, very steadily, no problems. That stepper motor driver seems to be the problem on the X, because it would run well and then it would stop, and it would run well and then it would stop. So what we have to do is adjust the current to that stepper motor. And you do that with a very small screwdriver and a multimeter. And so we'll go down into FarmBot, we'll make those adjustments on the X1, and then we'll try it again. So inside of the FarmBot, we've got some interesting pieces here I'm going to point out. I'm going to show you specifically the stepper motor drivers and how to adjust them. Up here is the Raspberry Pi. It primarily handles all of the web connectivity. Down here is FarmDuino. It's a custom board made by FarmBot. This one's the FarmBot 1.4. And you'll notice these red chips in here. Those red chips are the stepper motor drivers. They basically provide the power to those motors that we were looking at. Interestingly enough, these are separate devices. You can actually pull them out like this. It's a separate chip. We'll zoom in on this for a minute because it's kind of important. You'll notice on this chip, and this one does not have the heat sink on it, but the heat sink comes in the package, it just glues right on there. I have it removed on this one so that you can see the board a little bit better. This is the top edge of the board here. There's the chip, and this little silvery cylinder, disc here is really important. That is a potentiometer. It's an adjustable resistor, basically a knob you can turn. And turning that knob changes the current limit to those stepper motors. In other words, this is how you can give them a little more oomph if they're a little bit weak. Now, you can measure the VREF, they call it, a voltage reference, that it's currently set at, and then you can make adjustments to that with a tiny screw and check it again. It's a little bit confusing because to measure that voltage, you need to measure two spots of any voltage anytime. One of them is you actually put one of the probes of your multimeter on this little disc, what they call the wiper of that disc, the outer edge of that disc. The other one needs to go to ground. So I'm going to turn this chip over and show you here that it actually does have a ground pin on it. Let me turn it this way so the light's a little bit better. See how it says G and D right there? That's the ground pin. Okay? When you flip it back over, that's on the upper edge right here. So I'm going to measure the voltage between this pin and that wiper that my thumbnail's touching. I'm going to reinstall this and get my multimeter to show you. One minor thing I can mention while I'm getting my multimeter here is that I live in Miami. It's very humid out here, and so I don't have to worry too much about static electricity. But if you are pulling those guys out like I did, removing those stepper motor drivers, and it's dry or particularly staticky, you're going to want to take the precautions for that. You want the anti-static gloves or an anti-static mat. You may want a ground wire coming from a wristband or something like that. But here in Miami, we don't really have that problem because it's just so humid. So I'm going to set up my meter right here. I don't know if you will be able to see it and what I'm doing at the same time, but we'll try. So do you have the meter in the shot?
Yeah, go ahead.
Okay, so I'm going to put my ground pin of my meter on that ground pin there, ground probe. And the other one I'm going to put directly on that wiper like this. And if you look at the screen here, it gives me a value of about 0.78 volts. That's VREF. Now what's confusing about VREF is you actually have to divide it by 0.8 approximately to actually get the current limit that these motors are experiencing. I can show you that in the app where it gives you, or not on the app, on the online help, where it shows you how to actually calculate what that current limit is. But it's about that divided by 0.8. So right now it's limited to 1 amp. These motors can handle about 1.7 amps, so I can crank this up quite a bit. To do that, let me get my tiny little screwdriver here. I'm going to bring it in onto that screw, just like that. You want me to move this wire out of the way here? Is that better? Mm-hmm. Okay. I'm going to just give it a turn. Turn it about like that. Now that I've turned it some, I'm going to double check the voltage again. Let me set this up. It's now reading about 1.1 volts. Okay. That's a little higher, but I want to try to hit pretty close to about 1.6 volts. So I'm going to turn this up some more. If I can hit about 1.3 volts, I'm sorry, 1.6 amps. 1.3 volts is about 1.6 amps. 1.26. That's close enough to 1.3 for me. So that's going to be running about 1.6 amps. Still a little bit of safety margin for these motors because, like I said, they can handle 1.7 amps. Now that I've readjusted the current limitation on the X1 stepper motor driver, I'm going to move the X1 motor connections back over here, and this should give that motor a little more power to do its thing. Let me move this into here. So X1's back at X1. I'm going to re-plug in my Y1 because that was working fine. I certainly don't want to mess it up. Okay, so this motor now should run much more cleanly and reliably now that I've turned that current back up. So let me tell it to go a meter. And it still seems like it's struggling. It's having some problems. So the next adjustment that I can make to help, again, try to eliminate any variables is I can use the software and I can actually turn off the always power motors option. By turning off the always power motors option, what this does is it means that when it's sitting still, it's not using power through that stepper motor driver to keep it in place. Unless you've got, somebody pushing on this thing or wind blowing on it or it's on a crazy hill, it really doesn't need that holding power. And so by turning that off, I'm saving electricity for one thing, but I'm also taking it a lot easier on those encoders. So let's see if turning that off helped solve my movement problem. Again, it's all incremental. Everything we do is getting a little bit closer at each time. It's still not quite there. So the last thing I can try, the last thing I can do to sort of eliminate variables is I actually can tell it to ignore the encoders altogether. So I'm going to turn off enable encoders and I'm going to turn off using encoders for positioning on the X. Let's go back into the controls one more time and let me tell it to move and let's see what happens. So I think that's pretty convincing that it's reached a point where this motor can move continuously with the commands it's been given. I do want to check on the other X motor just to make sure it's working, but we don't need to do that while we're making the shot. The next thing I'm going to do is I'll put the belt back on, I'll retighten it, and then we'll see if we can get this whole thing to move. Okay, so I've reinstalled the belts. Again, the encoders are not operable right now, but we know that the two motors can turn in the same direction. The encoders are agreeing in which direction it's going. They have enough power to kind of power through rough spots. So I'm going to see if I can make this gantry move. And as you can see, it seems to be moving fine. Got a plant in the way here, but it seems to be able to push that plant out of the way just fine, so it's not binding up on that. I've told it to move about a meter, so it should stop somewhere around in here. Yeah, it stopped at about 1 meter. So the problems are solved. We had an X-axis that wouldn't move at all, and now it moves really, really well. The last thing we need to do is we want to try to enable those encoders. I suspect that when the belts were off, it wouldn't quite run properly with the encoders enabled because maybe one motor is turning a little bit faster than the other, and it would detect that it was getting misaligned. Now with the belts in place, they're actually physically moving something. I predict that they'll be able to handle the engagement of the encoders no problem. So I'm going to tell it to come back to 0 here. Let's see what it does. Both sides are moving. They're moving together well. It's using the X-axis encoders for the purpose of positioning. You did get a little bit of a stop right there, which will happen once in a while, especially if you've got any kind of mechanical friction binding or anything like that. It'll occasionally stop. There's one setting actually in the devices that you can do where you can take the number of attempts that it makes. It's called maximum retries. The default is 4. I turn it up to 10. And so that way, when it comes time to run a long sequence, like the one where I water my lettuce here, So let's see what it does. The z-axis is working well. We actually have it set where the z-axis is 0, is all the way up, fully retracted. We also have installed our tools at the far end of the X, so when X goes to 0, it's all the way back against here. That's at 0, and then the Y-axis is all the way to the right. So now it's coming down to pick up that watering tool. And so now this is really the moment of truth for us on our X-axis adjustments. Will it be able to make it all the way to that lettuce plant without stalling? That particular plant is at 2.8 meters from the home position. So it's moving a good almost 3 meters here to get to this lettuce plant. It hasn't run into a single problem doing it the whole way. It'll water this lettuce plant for about 10 seconds. The water will stop, and then it'll initiate a sequence that returns the watering device to the tool holder at the far end. Really, this last X motion is going to be the one that's our true test, because our FarmBot is actually on a slight hill, and so it's a little bit harder for it to return to home than it is for it to move out toward the plants. One thing you might notice about this sequence is that it retracts in the Z all the way, comes home on the Y, and then goes home on the X as 3 separate events. The reason we do that is because the total current demand running all 3 motors simultaneously can be somewhat taxing on the electronics. Again, the X-axis is moving perfectly fine now. It hasn't hung up, it hasn't jiggled, it hasn't jerked. Well, it did one, just when I say that. That's 2. I currently have it will give 10 tries on a particular run. So 2 minor little jiggles like that, probably where it was hitting that plant over there, shouldn't be a big deal. When it gets to a position of 200 millimeters out from the home position, it'll bring that Z-axis down to hopefully align the tool right in line with these brackets here. That Z adjustment's very, very finicky here. You have to make sure it's exactly right. And it actually looks a little bit to me like my Y is off. Oh no, that's actually really nice. It's the X that's off. It doesn't quite realize, the very last of this didn't finish when it retracts, because the X, I think I need to re-zero it right there. But other than that, very successful improvement on the movement along the X-axis of our FarmBot here at Ransom Everglades. Thank you.